Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video today is something that you should learn, every C++ programmer should learn as they get into object-oriented programming. But this very well could be something you're asked in your technical portion of a C++ interview. So the question itself is, what comes for free in an empty class declaration? And what I mean by that is something like this. I have class empty, just curly brace, nothing inside of there, but what functions and what can I do with this empty class without having to define and declare and develop all of the functions myself? What have default versions that I can go on with without having to worry about? And I'll give you the spoilers right here for those of you who want to click in and click out and get out immediately. Let me just wait 4 seconds, so at least you get 1 minute of time here. And there we go. And what you get are these 6 functions until 2011. Until 10 years ago, which nobody cares about anymore, there were only 4 of them, and then 2011 popped up, and now we have 6 functions that come for free. So we're going to describe every one of them. We'll show details, we'll show examples, and we'll also take a look at why we have access to these things. Why don't they just come for free and stay for free forever? And that's the idea of a shallow copy versus a deep copy of an object. Sometimes you want shallow copies, sometimes you want deep copies, and if you want deep copies, you generally have to start writing the code yourself. Okay, so the first one on my list is Constructor. Here I have a header file empty.h. that has exactly what we see, just nothing going on inside that class. I set up a main function and a main file so I can access this include file and just do what I need to do. But you can see if I just set empty e, this will run, this will compile, and yes, that's the first one, is the constructor comes along for free. I'm just going to make everything public. I know that goes against data hiding, encapsulation, or just data hiding kind of stuff, and just the way things go. But for the sake of this example, it makes it easier. So let's say this function, the constructor, comes for free. The default constructor, no parameters passed in. So it's one of those things here. So if I want to overtake that, I have to write this. This is the syntax for writing it out. I develop it. I'll create it over here in the CPP file. And for right now, I mean, basically that is what you're getting for free. Empty, empty, and the more I look at the word empty, the more weird it looks. And so no parameters get passed in, nothing happens because there's nothing to initialize, and then we're good to go. And for good reason, there's no reason for you to define that and declare that every time you go, because nothing is truly going on. And so just, so like if, oops, did I save that? I think I saved it correctly. No linker errors, good. So yes, it runs just the same. But now this is where things start to get a little hairy with not just constructors, but everything else. So what if I have a value called int, and over here I set this thing up and I print out this e dot, did I call it x? Yeah, x. So what if it has a member variable inside of it, and I call the default constructor either with the code or without? It doesn't mean, let's just to say, let me just get rid of this. Let me see, can I do this? I cannot have, okay, I'm just trying stuff out. It's, how often do you do these kind of crazy things? But if I run the constructor without, the default constructor that comes for free, I will see that uninitialized local variable EU. So that's not even allowed. So I mean, I was not expecting that to happen, that kind of error, but it's good that that happens. It's good the compiler tells you, hey, you're uninitializing data. And what that means is the default constructor will do nothing to set up X. And so the compiler is complaining because basically X is going to be garbage. It's going to be, it's going to either be that negative 858 million number that comes in Visual Studio, or it's just going to be random uninitialized data. So that's a problem. So that's why we need a constructor to take over. Even if we have it as an empty constructor, it probably makes sense to come on over here and just say, okay, let's just set X to 0. And make us feel better about things. I like to put the nothing here so that you can see what's going on. So now this will run because the default constructor we took over, and we go, okay, we made it 0. And so, so again, all these default behaviors are here just to make your lives easier, just to kind of get you started. But once you start making more complicated classes and objects, you can see how things can start to pile up here. So the default constructor is fairly simple. So the second function, if there's a constructor, I mean, we notice it, we don't notice it kind of thing, that if there's a constructor and I run my program and I end my program, there has to be an equal and equal destructor. And that obviously came for free because it didn't ask me to prepare it. It didn't ask me to do anything about it. And so there's only 2 times generally that you ever have to go ahead and create a destructor yourself. And that's why if you notice in my previous videos when I'm teaching just the normal stuff, until we get to inheritance and polymorphism and dynamic generation of data and arrays and so forth and so on, that we don't have to worry about a destructor. The destructor just automatically gets called. So the 2 times we need a destructor, let me define this and I can put that over there. I do not personally like having that thing open up, so I like to have it like this. Oops, that didn't go. Second, come on. How do I drag it in? Oops, did I kill Visual Studio? I broke Visual Studio, or what did I do? I don't know what I did, but let's see what I can do now. Nope. I have crashed Visual Studio. Normally I would stop this, but this is like a badge of honor. I crashed Visual Studio. I found a way to make it happen. I didn't even do anything to it. Anyway, so let's see. Will it happen again? Like the universe is conspiring to say, I will not be allowed to make my life easier. I did it again. Okay, so give me 1 minute to fix this up on my end, and we'll talk here in a second. Well, this is getting me nowhere, so I'm just going to not worry about trying to make my life easier. And so here is our destructor, and the general rule is the 2 times you need a destructor in your class. The first thing is when you use dynamic memory. So dynamic means when I new something up. So I don't have anything newed up here, so these are value types. This is part of the class declaration. This is part of the class, it's part of the object, and it's not a pointer or anything. There's no memory. So when the object destroys itself, I don't have to go in and tell it delete X or do anything crazy. But it is when I go ahead and maybe instead of being an int, I have an int pointer, and then maybe I come back to here and say, okay, X is not, instead of 0, say new int 0, because everything has to be a pointer to something. And so again, if pointers are what is a pointer, you're screaming out what is a pointer, then you should go back to see my previous videos on pointers and structures and so forth and so on. But okay, but if I have a dynamic memory, the rule is always for every new, because I'm supplying the new, I must supply the delete. And it doesn't always have to be in the same class. And this is where the fun old memory leaks sort of thing kind of happens. And even if I don't declare the destructor, it will still have a memory leak unless I go in here and I say delete X. And so for those of you in my advanced C++ class, we will see this in more detail when we get to talking about all the advanced data structures and like how they work under the hood, the vector structure, the list, and so forth and so on. And so without this, we have a memory leak. The pointer, which is 4 bytes large, at least on this system right now, might be 8, depending. It could be any. It could be 2, could be 4, could be 8. Depends on where you are using this program, where you're compiling it on. But most likely right now in 2021, it's 4 bytes, at least in Visual Studio. Every time you create an empty object and then it gets destructed, you're losing 4 bytes of memory to your operating system. And the operating system, and that's terrible, because over time, if I don't do that, eventually the thing will crash. So let me just, since we're just talking out things, let me comment out the delete and just say in the source here, I can just say while true, not while new. Just do this, and I don't care about printing anything out, and it might take a few seconds. And oops, empty e, undeclared identifier. Oh, down here. Let me just get rid of it and comment that out too. That's all that was. Okay. So it's going to take a while, because it's killing things. 4 bytes, 4 bytes, 4 bytes, 4 bytes. And I've got 16 kajillion, trillion petabytes of RAM. Not really, but it's going to take a little while. Boom, boom, boom. So what's going on, everybody? How you doing? Oh, there we go. Unhandled exception, bad allocation. And that's because every time I new this thing up, it creates a brand new, it asks the operating system for 4 bytes of memory, and it gives me it, and then when I get to the destructor, it doesn't give it back. It doesn't tell the operating system that we're done with it. And so, without going into too many details here, with this delete, now it'll run forever, because it'll new it up, then it'll get the memory from the operating system, it'll give it back to the operating system, and everybody's happy. And that works for any kind of pointer. Pointer to variable, pointer to array, pointer to vector, pointer to object, pointer to you name it. It doesn't matter. That this is when you want to use the dynamic memory. And the other time you want to is set up a constructor is when you have inheritance, and this is the base class for that inheritance. Because virtual destructors, you'll have it's the same idea. You'll have a memory leak. If you have, class A derives class B and B derives class C, if you do not have a dynamically generated destructor, it'll only destroy the base part of your object, and it will not destroy all the others. So if you know this is a base class, then instead of just being a destructor and you're defining it, you have to have a virtual destructor. So it's just so you're clear on that. So just generally speaking, you don't even need either one of these things. But if you have newed up memory, you need a destructor to make sure that you manually delete everything. And if this is a base class, make it virtual, and you are good to go. Okay, so that's all I wanted to say about constructors and destructors. And now we're ready to move on to the more difficult things. Okay, so items 3 and 4 on our list now are the copy constructor and the copy assignment operator. And at the end of the day, basically, a copy occurs. I mean, that's just copying from point A to point B, all the data from point A to point B. But at the end of the day, these two things are completely different when it comes to how the compiler works, and they are obviously they're two separate functions for separate reasons. And let me just write these things out, and then we can discuss. So the constructor itself is empty. That's the name of it because it's a constructor. And what you generally pass in is a constant reference to something. I always use RHS because it's the right-hand side versus left-hand side. And I have a video of what that actually means. And the copy assignment operator is completely different. And this is going to return an empty reference. And this is going to be operator equals. And then this is going to pass in, since we're doing equality, we're going to say empty reference just the same on the right-hand side. You're like, oh my goodness, look at all that. That is, I mean, this isn't the print operator or the cin or cout operator, so it's not overly complicated. But the equals, say we bring in an object, we're going to copy data in, and then we're going to pass it along, because if we're going to chain equals A equals B equals C equals D, then we need to do things this way, because we don't want to pass copies, because at the end of the day also we want to make sure we are efficient and we don't make unnecessary copies of objects and data just to get a job done. So there's as a professional programmer, your job is to get the job done, but it's also to do things so the computer isn't working its butt off just to do simple things. Okay, so I'm going to define these guys over here, and let me just find, cancel. And let me go over here. Here they are, right? Okay, so we've talked constructor, destructor. So copy constructor is a constructor. So because of all the newer stuff here, I can call other things here. And what I can say is my x value, which at this point is a pointer to a bunch of data, is I can just say it's going to be equal to RHS x value, and I can say nothing here. And this is what's actually happening under the hood, because it's just a pointer. Even though we have newed up memory sitting here under the hood, it's still just a pointer to that beginning of the allocation of the memory. So in our case, we've newed up 4 bytes of memory for this variable, and so it's a pointer to that memory address, and we're just saying take that memory address and copy it over. And so that's that when it comes to this, and you don't have to do anything more you just use the initializer list, and everybody's happy. And so now it's pretty much the same thing here, on the other side, but this is not a constructor. This is an operator. So I basically are doing the same thing. I'm just saying x equals RHS.x, and I have to return star this. Oops, return star this, not just a frizz. Hold on. Okay, return star this, because I'm returning a reference, which is a reference is the same as a pointer, just with different syntax. 95% correct. And when I do this kind of thing here, when I return star this, I'm returning a memory address to me, the object that data just get copied into, so I can chain this thing along again. So I can say A equals B equals C equals D, and then the next equals operator, I will be the right-hand side, and the new object on the left-hand side will be the object we're copying the data into. So right now, right here is where we can start getting ourselves into trouble when it comes to what we call shallow copies versus deep copies. Because what we did here is a shallow copy. We basically took and we just copied all the raw data that was in the one empty object, and we copied the raw data over to the other one. And you're like, well, what's the big deal there? Let's go into here. Let me just start changing this up just a little bit. And let me just say empty A, empty B, passing A, and empty, and then let's see, and then I can just say empty C, and I can say C equals B. I don't really have anything here. This is just copy assignment. Okay. So let me just start with this. I have 3 objects I'm creating: the regular normal constructor, the copy constructor, and then this is a default constructor as well, and then this is actually a copy assignment. Let's just go through and look. Let's use the debugger and find out. Okay, so I run. Okay, I go F11 to go in. So A is constructed using the default constructor. All right, and then now B is being used with the copy constructor. You can see that here. We're going in, and so everybody's happy. And now empty C is using the default constructor again. And then now this next guy is going to use the copy assignment operator. And there we go. So what's happening here? Let's discuss that. This is using the default constructor. That's obvious. This one uses the copy constructor because in my line of code, the copy constructor gets used when I'm constructing an object, and on the same line of code, like B does not exist at the current moment. I'm creating it on this line of code, and I need to use A as the template for all the data I want to copy over. So A exists in memory, but B is being constructed right now. It does not exist right now, so it uses the copy constructor. And so now C, because this is the default because it's being constructed, and then C here, or the line 9, this last one uses the copy assignment operator because we are not creating any new objects here at the current moment. C exists in memory, B exists in memory, but I'm copying from B to C. And so that's why that occurs. That's why they're 2 separate functions. They do the same job, but they do things in completely different ways. And I was saying earlier, if I don't include the reference return to this equality here, I couldn't do something like this. A equals C equals B. If I just return by value, then things get a little weird and copies get made and all sorts of things. Or if I return by void, which you can do, and say I don't want to complicate things too much because this is supposed to be just an introductory video to these kind of topics. So, but just understand then, that's where we're coming from here, the big difference. But now, another thing here is what's going to occur if I do something like this. I'm going to do a printout. I'm going to do a.x, and this is only allowed because because I have this as public data. If I was doing this for real, I would do things with private data, use the data hiding and everything else. And I'm going to do this here. Okay, so I'm just going to print out. Let me get rid of my breakpoint and say this will print out 0, 0, 0, right? Nope, it does not print 0, 0, 0. It prints out something weird, and that's because X is a pointer. And if you say, I just want to print out the data that X is, this is the memory location. And maybe I'm already alluding to the problem between a shallow copy and a deep copy by looking at this. Whoops, things are not happy. And so what I want to do here is say, I want to take a look at dereferencing a.x. because it's a pointer. I want you to get me that memory address, but then I want you to tell me what's stored inside. That's what I'm more interested in the current moment here. And so this should print out 0, 0, 0. Oops. But the problem now is, what happens if I go down here and I say a.x, well, I guess star of a.x, or I guess I could use the arrow. Maybe I can, maybe I can't. Equals 5. Can I do that? That's always it's always the fun of the syntax here. Expression must have a pointer type. I'm not allowed to do that, so I have to do a.x equals 5. So this is saying, okay, I know what memory address. Go in there, go where the data is, and put a 5 in its place. But now, what happens if I do something like this and I print a second time? And I already alluded to it earlier. And what happens is I have 3 separate objects. I've changed the data in one of them, but it's affecting all 3. And it came back to when I was printing out those hex codes there, what memory address is being stored inside of a.x and b.x and c.x. They're all pointing to the same memory location because it made a shallow copy of the data. And that's why there's only one piece of data. This little guy here will show you what's happening, that I only constructed things. Okay, so let's do a visual example of what's happening here. When I set up empty A, what I'm doing is I'm newing up memory that's pointing to here. Okay, and then, because that's what the default constructor does. And so it fills in a 0 in its place here. And this is the memory address. So I'm just going to call it 99 just to make it easy. This is memory address 99. And so this is a pointer. So this stores memory address 99. It's not storing the 0. That's why we have to dereference. That's what the whole pointer is. The number stored in here is this memory address. And then to be able to get the data, I have to say go there and then do an extra step to get me the data. That's what's happening here. And so now what we're saying is empty BA, we're not newing up any memory with the copy constructor because that's not what this is doing. It's saying, okay, the X value stored inside of me is whatever this one is. So we're going to say, oh, this is here. This is now, number 99 here. And so now the third one here, empty C, does exactly the same thing, but now this actually news up a third piece of memory. So this isn't what you might think it is. Let me do this just slightly like this so I can see this and bring this over. Bring it down here a little bit here and say this is some completely different memory location. Who knows what? But I'm saying the same thing goes here. I'm setting it equal to 0. And then now what's going to be stored in here is this memory location. And you're like, well, that's not what I saw before. That's because this guy ruins everything. Because it's saying, oh, now I'm going to take whatever's in B and copy it over to whatever's in C. And so this is you got to watch out for this, is what's happening now is that basically it's just, since this is a shallow copy, this is going ahead and saying, okay, whatever's in B goes over to here. So this is now not star 9 or address 99. This now we can move up a little bit. And we have a memory leak now because there's nobody pointing to this memory anymore because we just changed it up. We just said now everybody's pointing to the same memory location. And this guy is lost to time, and until your operating system or your program ends and your operating system gets the memory back, or maybe even never, depending on what kind of architecture you're working on, this memory is gone forever. And it's only 4 bytes, but yeah, if like when I worked in slot machines, like if this program is supposed to run forever nonstop, 4 bytes here, 4 bytes there, 55 days later, the game crashes, and to you it might not be a big deal, but it was a big deal to the casino industry because the games are supposed to run never have to have any worry that they need to be turned on and off again ever. And so 4 bytes here, 4 bytes there is an actual big problem. So this is already an issue when it comes to setting things up. But now coming back here, since everything's pointing to the same memory location, as you can see, if I change this number in one place, it affects everybody. And so you can see when I go to print everything out now, it's like, well, now they're all 5s because it doesn't know any better. They're all pointing to the same place. And so the last step here to do the deep copy so that everybody's looking at a different number value, and we can prove it by writing some deep copy code. So remember again that that X is holding a pointer to where the actual memory is, where my integer value is going to be stored for its individual object. And so now the default constructor is perfectly fine. It's setting up a value, and if I wanted to, I'm not going to do it. If I wanted to set up, you could put in a default constructor or a default parameter here to set the thing to something other than 0. But we don't have to do anything more. It sets up it news up something, it sets it to 0, and let's say we've already proven that in my Excel code here by doing that here. Let me just delete these for a brief moment. This is what's going on when I do the default constructor. It gives me some memory, it news up some memory, and it puts a 0 in there, and then now it's pointing to that. And if I went ahead and set it up one by one by one, everything's going to be fine. Everybody's going to have a new memory address. We kind of showed that the second time I generated this. But now it comes down to, what do I want to do with the copy constructor? Default, say we're already deleting X when things are done. That was another actual problem. If we're pointing to the same memory location 3 times, and every object is now being destroyed when this closing curly brace gets hit, because actually when I run this program, it runs and then it crashes. And that's because when I hit the destructor, I'm deleting X, which is a pointer. And so what's happening then is, now that the memory's been given back to the operating system has full control. So when the second object goes to try to delete memory that the operating system is now in control of, it will crash on you. So a few ways to do, one way is to not do things this way. I would say that's the easy, that's the rest of the owl kind of thing. But now is just to set this up, and it still crashes. So you got to watch out for that, because sometimes like deleting a null pointer and whatever else, because again, this works for this object, but it doesn't work for the other objects that are still pointing and dangling and looking at this, that memory location. So coming down here, what can I do instead? I can say I can new up an int here, and I can put the value of the X value of RHS there. Type int. Did I not use int? What did I do wrong here? Hold on, give me 1 second here. New int. X is a pointer. New int. What did I do wrong? That's always the fun part. What did I do wrong? Integer cannot be used. Or type int. Or do I just need to star it? Yeah, if I forgot all about that. That's syntax is so ungodly when it comes to pointers. That's why most modern languages got rid of it, because it's just it can be a pain in the butt. Okay, so there we go. So get me the X value of RHS, get me the memory address, dereference it, and put it into a new memory. And now things will be different. That's all it took. And now you can see the one value is 5 and the others are 0, because now, and it still crashes, but just give us a minute here. And so what's happening now is the 5, going back to the memory, everything is generating a new memory address every single time. I can bring this up now. I can bring this over now. Oops. Yeah, bring this over now. Everything gets its own memory address. I'm just making up numbers just to kind of get my point across. And every time I go through here now, I'm going ahead and doing this. And so now everybody is pointing to new stuff. This is pointing to 99. This is pointing to 49. And this is pointing to 57. And everybody's happy now, because if I change one of them, like this, I change only this one that's pointing to that memory address. It's not affecting the other two. I can show that again. Here you go. That's what's happening here. So that with this, that's what's happening. It only changes in the one place, because now on a copy constructor, instead of just using the same pointer, I'm creating a new pointer every time to a new memory address, to a new memory address, to a new. And so now the problem comes down to this equals operator, because again, this is dealing in pointers. It's not dealing in values. So you could see how this is going down a rabbit hole of complexity. So this is saying now I need to say, okay, star x is equal to star of RHS.x. And I like to put the parentheses just to be a little more clear what's happening. And now we won't get that crash. Run it again. Now we won't get that crash. And why won't we get that crash anymore? Now the program runs and it doesn't crash on us, because instead of swapping pointers around, and again, coming back to the idea of this here, swapping pointers means we're just moving what these things are pointing to, but we're not deleting any of the memory, we're not moving anything around. And when we if we ever go to delete the same thing 2 times, we're going to have a crash. At any time, not just at the end of a program, but any time you try to reference a dangling pointer, the program is toast. And so in this case, instead of moving pointers around, we want to move the data around. We want to move what is stored inside of here from pointer to pointer, from memory address to memory address. We do not want to pass the pointers around. So this is saying to get the value and copy it of some memory address, go to another memory address and copy the value into there. So that's a lot to go on there, but that's exactly what's happening in all these situations. This is dynamic memory. This is what we're going to deal with the vector class. Currently over 2,000 views. Apparently it is something that a lot of people are using for their studies. But pointers, it's one of those things. Pointers was the scariest thing in the world to me for a long time. But once it clicks, and once you can deal with pointers and pointers to pointers and things like that, you understand architecture. You understand how a computer works under the hood. You can do anything in any language once you understand how references and pointers work. So that's all I wanted to speak about. It's been a while here, but that is everything that you kind of want to know about copy constructor versus copy assignment operator, deep copy versus shallow copy. All right, so parts 5 and 6 of this are move constructors and move assignment operators, but to kind of show this off in a different way, I have to set up some kind of operator first so I can create a temporary variable on the side. So I went ahead here and I'm just creating just the plus operator. This does not come for free. This is just something that I'm doing just to kind of make my point for parts 5 and 6. So we have to fix this up a little bit here. So because it's a plus operator and I'm creating a new object, I'm not using myself or anything like that, because this is something like A equals B plus C. Right, so what's going to happen here is I am the left-hand side, the C here is the right-hand side, but I'm generating a brand new empty object, and so this thing is no longer empty, but that's okay. And so this new empty object is going to hold what the value inside B is and what the value inside C is, add them together, and then store that. So this is not a copy assignment. I'm not creating anything. It's not a copy constructor. This is just generating an empty object. So what happens here is I go ahead and you'll see over here when I define this thing, star x plus, this is what I want, but the compiler is giving me a problem because I don't have a constructor developed that can take in a parameter. And so what I can do here is just come back to this and just say int x equals 0. Let me just use a different value than x, call it a. And say a equals 0, and so so now this has to be fixed up over here on this end, and all I have to do is just say int a, and I can just put a here. That's just the general way we can use the default parameters and things like that. Now everybody's happy. This will call this constructor passing along this value, and if I don't supply one, it'll supply 0 for me automatically. So right now nothing changes because I'm not using the thing for anything, but I just wanted to show how you go about doing something like this to set up the other operators that don't come for free. Okay, I'll give a quick little description here finally we're on parts 5 and 6, the 5th and 6th thing that comes for free. So again, 1 is constructor, 2 is destructor, 3 is copy constructor, 4 is copy assignment operator, 5 and 6 are more of the same with 3 and 4. But now we have this idea of a move constructor and a move assignment operator. Oops, this whole time I spelled operator wrong. Oh, well, I figured it out at some point. Okay, so this occurs, the move constructor and the move assignment operator are used when you're creating temporary objects that are part of a line of code. So something like this. That's why I created the plus operator a minute ago. So when I say C equals A plus B, when I get to here, the A plus B, this is an empty object, this is an empty object, it generates and creates a brand new temporary empty object, which then gets copied into C. So there's like, you don't see it, but there's one extra object that's part of the chain here. And so like if it's an integer or float, you don't necessarily care. But as we've shown here, and we've been doing this entire time here, we're moving memory around, we're changing and newing and deleting and doing all sorts of crazy stuff. I don't want to copy all of that over just to copy it again and copy it again and copy it again and new and delete and new and delete and new and delete and just waste time when I know I'm just trying to get the answer over into C. So move means exactly kind of what you think it means. It means take the data we've already done, don't new anything up, and just pass it along, string it along, because it's already been done. It's already been created. So again, this website here will show you much more detail than I ever will. I've never used this per se in professional code, because right when I was getting out of the industry with my company, that's when this was starting to become a thing. And I don't know, it's one of those, I don't know how much of a big deal it necessarily is these days. But anyway, it depends on the objects and depends on a lot of extra factors. It's much more complicated than it might sound, and if it sounds complicated, it's more complicated than that. But notice that the constructors are similar to the constructor and assignment operator for copy. It's just now this gets a double ampersand with no const, and this gets, it's a single. It's weird because it passes in a double ampersand and it returns a single one. But none of these are const, because you're going to see here in a minute, we're actually going to be modifying these objects on the right-hand side to pass the information along and make sure that the data gets from point A to point B to point C to point D. Okay, so that's how you would go ahead setting them up. But then now defining them, it's it's called copy and release, and again, it's in that link here. But what we're trying to do from a temporary object over to a different object, instead of newing up like we've done for everything else, right? Constructor, new. Copy constructor, new. Well, no, we're not trying to new anything up, because we're just trying to pass the information along, because it's a copy that's just getting strung. So what we do is we just take, oh, my x is equal to your x, because you've already newed up the data. So that's as far as I need to go here when it comes to this. And if it wasn't a pointer and it was just plain data, it would just be a normal copy. A equals RHS.A. It doesn't, it's basically, it's essentially a shallow copy. We're just, we're just shallow copying the data so we don't accidentally go about and do a deep copy. So it's like the opposite or the contrapositive or whatever of whatever we've done in the past. So copy and release. And then once we've moved the data over, then we can delete it essentially, but we're not going to delete it. We're just going to make this a null pointer just to make sure that everything's cleaned up on the RHS side. So that's how the constructor would work, because X ends up how it's supposed to be. So for whatever reason, I'm just following their pattern. I don't know why you set it to null pointer when you immediately then set it to this, or you could just probably put it up here even. Maybe it was just their example. But now for the copy assignment operator, things are a little more complicated, because what's going to happen here is I'm moving data around, but what if I try to set A equals A? And if I go ahead and I try to delete my memory first, before I set everything up, because you don't have to delete anything here because things are coming in fresh. Things are a null pointer. But here you don't know much of what's going on. So I'm going to delete the pointer and then delete whatever was pointed to previously, because nothing is pointed to right here. But then set it all up and then release it just the same. So the copy and the release is just I'm deleting the memory because it's a pointer. But what if they were the same? I'd be deleting myself, and then RHS is me, then I'd be like, oh, set my X to whatever the RHS X is, but that's deleted memory. The operating system has that memory, and you're going to get a crash. So that's where this if comes from. But at the end of the day, again, they get you to the same place. They're copying data from right-hand side to left-hand side, but you can see that this can be a big problem. And then I'm returning an empty reference, because then I can chain and chain and chain again, just like I did before. And so just to show I can get to this point, run my program, you can see C equals A plus B. Oops, hold on 1 second here. C equals A plus B, I hit F11, it's going into the plus operator. It's creating this new one, new empty, using the normal constructor. But when it comes back now to everything, I know it's hard to see, A plus B came back, and now there's a temporary that goes into C. And see, now you can see I'm in the move assignment operator. And RHS is this data that stores a 5. But now I can go ahead and make sure everything works out like it's supposed to. Everybody's happy, and everybody can print just like we were doing before. And now you can see all the data comes out like we're supposed to, and there's no crashes. Or that's the big one, right? There's no crashes. Everything came out like it was supposed to, and all of these functions are now part of this. The move, again, it's 10 years old at this point, and for me, that's new. 10 years in computer science can sometimes be a lot, and it sometimes can be a little when it comes to, you know, the way technology advances. But that's everything. Those are the 6 free functions that come for your C++ class. Even if you never get asked this in an interview, this is a big deal when it comes to programming, because you want to make sure you're a professional programmer, especially if you're going to work in C++. And this is a big one, and especially now that they've introduced the move operators to make your lives easier, spend that extra time and learn how it all works so that you're not newing up and deleting memory all the time. So as always, if you have any questions, swardb@cod.edu is a great way of getting a hold of me. Commenting below, especially about the move operation, since that's the stuff that I am the least up on at the current time. I just did my best to try to describe it for you, and maybe I did a piss poor job, but maybe I didn't. So I don't know. Just let me know, and I'll be happy to correct anything that I might have said incorrectly. So as always, thanks for sticking it out with me. We'll see you guys at the next video. Have a great day. We'll see you then.